don't know if you want to say something, otherwise I introduce. In the meantime, I just changed.
So, no, I just want to say thank to the organizers for inviting me to chair this session. I'm very pleased, and my name is Mario Cedrini. And actually, I'm an economist. I'm a historian of economic thought, economic methodologist here based in Turin. And it is truly my pleasure to chair this session, also because first speaker we have, Yves Gingras, is a scholar who did a lot also to investigate my own discipline, economics, from the philosophy of science perspective. So I am very pleased to introduce him, although I think that today he will talk about something more general. And the title of his lecture is How to Map the Changing Conceptual Space of the Time. So, Yves Gingras comes from UQAM, Université du Québec à Montréal, and on his slides.
It works.
So,
it works. Good.
okay, I can leave you the floor.
Great. Thank you very much. So thanks to invite me. Okay, since I realized I was opening the whole session, I thought it was good to take a survey of what we have done over the last 30 years about this thing. Of course, change words. Now you used to call it centrometrics, we do it. Now we call it digital humanities and all those buzzwords, but no, there's only so many things we can do with quantitative analysis. And we have information. So we have text, we have authors, we have addresses of institutions, countries. There's not an infinite number of things we have. We have references, citations. That's about the units we have. So the only thing we can do with those is combine them. And that's we see, and I'm glad you mentioned the disruption indicators. Okay, this recalls us that the whole number that garbage in, garbage out. Okay, people were talking about, oh, there is a less disruption, a lot of debates about that in nature or science. Then a few computer scientists found that there was a mistake in the data. But even before the data, there was in fact a mistake in the concept itself. The indicator was badly constructed, and nobody look at the indicator, they look at what it's supposed to measure. Okay? Same with H-index and all the pseudo indicators that we use without thinking. So I think it's very important to discuss about the indicator we use before trying to interpret the data. So that's what a bit we do. So as I said, there are a limited number of things. So we have co-authorship, and if we do co-authorship, we have authors, institutions, countries, departments. We can look, which is less the case, but it's more difficult as a metadata, but we have acknowledgements. Well, for example, my colleague Vincent Larivière did a couple of years ago a nice paper about the fact that when we look at collaboration, we say, okay, there's more international collaboration in this, there's less in that, but they look at co-authorship. Historians don't co-author a lot. When I write my books in history, I'm alone. When I write in bibliometrics, I write with Vincent, I write with Madi. It's not the same discipline, it's not the same collaboration. So in history, we show that if we look at the acknowledgements, the kind of things about acknowledgements, thank you to every, Paul will have read my papers, I thank him, but he's not co-author. It's so common sense that are forgotten, in fact, by a lot of discussion. And of course, as I said, the author citation. Here, I will not look at the basic thing, which is the usual, for example, international collaboration. We can do a lot of that. A mapping of this is very interesting. I did for Encyclopedia Universalis 2 years ago. They asked me to look at the world transformation of science. And then we could clearly see the rise and the transformation of the collaboration of China with Africa, with Asia, the decentration from the United States. So we have a map there that is useful at this level. But I will not look at that. Here, I will look more at the evolution, since it was about philosophy of science. I will look at the transformation of the intellectual field, of the scientific field, of the Republic of Letters. Okay? And as you know, but I didn't know if everyone knows, so let's start with the basics. We have the bibliographic coupling and the co-citation. But I think it's very important to understand that those which are used without distinctions much, in fact, because we get a map with co something, okay? But it's two, I think, sociologically different things. The bibliographic coupling is an invention of the analyst. Okay? We compare A and B because A cites things and B cites without knowing it, the same thing. I think, and this is why I work essentially with co-citation, and here's the reason. Co-citation, the connection between C and D is done by the author themselves. So if in 1900 they cite A and B, it's not me who link A and B, it's the actors. This seems a detail, but it's fundamentally important, because then we can do really what was the connections between Poincaré and Einstein in 1905. And a lot of historians say, for example, oh, Einstein and Poincaré did both the same theory of relativity. I think it's historically totally false. For conceptual reason, for textual reason, but also we could show it for bibliometric reason. Because there was not much co-citation between Poincaré and Einstein, but a lot of co-citation between Einstein and Lorentz, because it was a link with Lorentz, not with Poincaré. And we could map it, and I will show up some of the map. So there is an historical way of doing co-citation, because it's a connection between done by the actors of the time. It's not me who decide that Poincaré is the same. Of course, for me, it's the same because the equations are the same in 2020. But in 1905, very few, in fact, nobody said it's the same theory. Now there's a new book at Springer that just came out, and who says that he solves the problem of the connection between Einstein and Poincaré, and he is a physicist by training, so it's not easy. So, and he invents a false problem instead of looking at the data and the things. Just as a reminder, you know, we talk about humanities already in the 1960s, at the very beginning of the Web of Science of ISI, Garfield and his group developed a computerized way to look at the spaghetti of citation. So it was not called humanité numérique, I don't know what buzzword, but it was a quantitative analysis by computer, it's an old approach. That is, I think it still works on the web, this old stuff, but I don't know. But here, in fact, I said, well, but it's interesting to look at co-citation not only in papers, but there's no reason that this concept is not applied to letters, because in the Republic of Letters, they exchange letters. So I said, okay, let's look at all the letters of the central networks of the people. In the 17th century, of course, it was Peiresc in the 1580s, Mersenne in the 1610s, and Oldenburg in the 1680s. That was the center of exchange. And of course, it's ink blot, so there's no interest in looking at that. But if we raise, of course, the level, we find something very, very interesting. Okay? Here, for example, if we look at we cut it in times of 20 years, it could be 5 years. Okay. Then we get the obvious thing that in the letter, the co-citation. So it means that when they talk about Aristotle, the probability will be high that they will talk at the same letter about Plato. So they make a link. So the link is done by the actors themselves, not by us again. It's very important. And we see that effectively, before 1630s, about with Descartes, it's called La Méthode, Galileo to new system, it's in the 1630s. So before the 1630s, the central networks is the old peripatetic philosophy. It's already clear just by co-citation analysis of the letters. And then if we go 5 years later, then we see now we have a central networks of the so-called modern ones, and the old one go to the periphery. And we get a very dense networks of course, Galileo, Descartes, and a few others. And the interest of this is that history of philosophy reminds only the central actor, Descartes, Galilei. But at the time, in the Republic of Letters, as much central as Descartes was, there were others who are now peripheral and very not known by, except by the historian of mathematics, to know the detail. But we tend to look at history of philosophy by looking only at the winners that we kept today. But at the time, we had a lot of central actors like Gassendi, who is less central, and a few others that have been totally forgotten, but were, in fact, in a very connected, dense networks. So those citations give us the first mapping of the what we call the Republic of Letters can be mapped really in its structure. The second thing which helps when we do, and then of course we could look at every 5 years on that. But the point of interest is that then we can calculate the centrality. And the good point of this is that we have then an operational definition of center and periphery. We can say, oh, you know, there is such thing as center. Now it's less. Center is the periphery, and the periphery is the center. I'm sorry, but that's not exactly how it works. There are centers and there are periphery. We can be shy of that. We can say it should not be that, but it's the way it is. Okay, so we can quantify it instead of having it as a metaphor. It's not a metaphor; it's a calculated centrality. And of course, if we look at the ranking, we see that the central actors in the 1610s is of course Aristotle, and then in the 30s it's Galileo in the letters. Of course, I took the case of Mersenne, but we can easily now imagine that all the letters of all those people are in one big database. Then we have the whole space of the Republic of Letters, and we could look at the changing centrality of actors, and no surprise, in the 1640s, Descartes. So the methodology works with, of course, the history of philosophy, which is a good thing, because then it would be a problem about historians. Okay? But now we have a quantitative way to do it in a scalable way. We could have letters. The point is to look at the letters as a database, not as a letter that we cite because, so all those letters were known, but they will never look as a database to be connected like that. And then we can generalize it. I did it for the Oldenburg case. And of course, we see, of course, there in the Oldenburg, the center is more linked to to England. We have Descartes in the 50s, Robert Boyle, and then we have Newton, who will appear much later because he's 6 in the 1670s. And of course, his first paper is 1672. So if we look at the time, we will see his centrality raised in the 1680s, of course, with the publication of the Principia. So we have a way there to map it. And then, of course, then I say, okay, we can do it with Darwin. And what is of interest? If we take all of them, of course, Darwin is a different thing because it's not the node of a correspondence. It's a family win. It's his. So we have the family and the scientists. And if we look at time, then we will see that in the network now we can have 4 information in the same network. In the one before, they were all natural scientists. Now we can put a color to know if it's a physicist or biologist, a chemist or whatever, and we can add a triangle. So we have more information in the same map. And here we have a lot of them. And then we can look at them over time. That, of course, at the beginning is the family. He's going in boat and he writes to his mother, makes sense. And when he comes back, he's more known as a botanist, as a naturalist. And then we see Lyell going up, Hooker, Gray, Huxley, and much less in the correspondence. His family is more centered. His letters are more centered on the scientist side, which makes sense again. So just as case to map the structure. And then, of course, we can, same thing, look at the centrality of actors. The family central in the 1820s, and in the 1860s, we have essentially the central scientists who know well, Lyell, Hooker, Darwin, Owen, the usual ones. But if we had not known already the detail of historians of biology, we have already a good map of the structure of the field. And then we go to physics, which is my center of interest. And then we can, again, look at the evolution of the centrality of the topics. And of course, we have the co-citations, but if we go back to the data, we have the title of the papers, and we could name the substructure. And if we apply a detector of community to that, we can get exactly the subfield perfectly. We show that. And here is a case where here we have the map of the centrality of physics in 1910. And we see black body theory, we see electron theory, we clearly see it there. And I did a map of the centrality of mathematicians, because I wanted to show that all the false debate between Einstein and Poincaré was in fact based on I think, of course, on a misunderstanding of the structure of the field of physics and the structure of the field of mathematics. Poincaré is totally central in the mathematics. He's a universal genius. So he reads papers by Lorentz. He corrects his mistakes because some physicists do maths, but they're not really mathematicians. So they have the intuition of physicists, write the equations, make some mistakes. Someone like Poincaré said, okay, I will make the clear correction. Here's the group structure, he does everything. But based on the real physics works by Lorentz. So when we map the two, we see that Poincaré is not really circulating in the field of physics. He's circulating in the field of mathematics, which helps us to explain that physicists will not see him as being a relativity. It's for sociological reason. So again, the map, and if we do it over time, we see very rapidly the changing structure. 1925, of course, it's quantum mechanics and Heisenberg, Schrödinger, because totally central. And after 25, 30, if we look at the centrality, Einstein becomes peripheral. We see it clearly. And if we look at that, we have it here. Here we take the whole field and we apply detection communities and we get the subgroups. Astrophysics, relativity theory, quantum mechanics, electron theory. It works. But the most interesting one is that, again, with the centrality. Here in gray, I said, okay, I calculate the centrality every 5 years about. And I do see the top 10, whatever. And then in gray, you have those who are in the top 10 for more than 3 time series, so for 15 years. And in all of them, except one, that then we can explain, all those who have at least were central for 15 years, they got the Nobel Prize. All of them, except one. And this guy is, what's his name? I don't have my glass. I forgot his name. But the only reason he's central is it's because he wrote the classic textbook. And he's the head of the school, but has never made a Nobel discovery. But all the others are central, but again, only for 15, 20 years, which is about a generation. 20 years generation. So it's incorporation thing. So you get Einstein. Okay, Einstein we know, so we don't have to cite it anymore every time we do relativity theory. So really the co-citation gives us an access to the structural evolution of the field itself. And when we talk about fields, we talk about a large scale. So we cannot go into too archival materials like historians do. Look at the archives of Einstein, look at the archives of Poincaré, then they speculate about the field. That's nonsense. The field is another scale, and the other scale needs new methodology that we call, again, numerical humanities or whatever first. Okay. Then I did the same for biology. Why? Because in 2005, if I remember well, there was a big fuss about DNA, 50th anniversary of DNA. And there was a paper, small paper in Nature. You know, Nature is supposed to be an important journal. And the guy was explaining that the famous paper by Watson and Crick on the discovery of DNA in 1954, finally did not really have impact before 15 years. As a sociologist of science, I said, that's not credible. Because they got the Nobel Prize in 65, 64, no, in 62, sorry. I said, well, 54, 62, it's 7, 8 years. The usual Nobel Prize is on average 20 years. So it's impossible that this thing was not. I said, okay, let's look at the bibliometrics of it. And if you do the bibliometrics of it, we see that in fact, between 55 and 70, every single year, the most cited papers of the years 54 in Nature has always been Watson and Crick. But then why is the mistake? The mistake was a methodological one, because they were looking at citations in Nature and Science. But then we have to go back, I think, to sociology. What is the difference between virology, journal of spectrography, and Nature? Nature is the buzz journal. There's no, you announce the big thing, one page, like the discovery of neutron. I discovered the neutron. Thank you. Then you go in Physical Review, in Conceptual magazine, and you write the 20-page paper. So where will the discovery be cited? It will be cited in a specialized journal. That's what I looked at, and I showed that there's a lot of citation in virology, in crystallography journal, because it's linked to crystallography, the DNA structure. And so it was based on a mistake of understanding that not all journals have the same social function. And I did a test with the discovery of the neutron, which is announced in half a page in Nature, but then it's not cited there. It's cited in Physical Review, Physical Magazine, Compte Rendu de l'Académie des Sciences, or whatever the thing is. So I think that we have always to go back to the sociology behind the dynamics of the journal and the hierarchy of the journal and the social function of the journal. The same thing that happened with the debate. So this debate was done by Historian of Biology. So I did a paper in the Journal of History of Biology to say to Historian of Biology, if you want to look at the structure of DNA, the reception of DNA in the whole field of biology, you cannot look at the archives of Cambridge University, because where they will find that the director of the department in 1955 wrote a report saying, oh, you know, last year in my department, there was not big action. Then they conclude that because the director of the department said there was not big action in Cambridge, that the DNA paper did not have impact. Of course, it's totally absurd, but that's the way some historian wrote the story. So again, I think it's a good argument that we need citation analysis when we ask questions about large-scale structure. The other thing we can do with those big data is that we can look at the impact of discipline on another, or the relationship between disciplines. So I did it for the first half of the 20th century, and no surprise, most disciplines are self-centered at the time. Mathematicians essentially cite mathematicians, physicists essentially cite physicists, and chemists essentially cite chemists, which just makes sense. But if we try to look at those who are beyond their field, interestingly, we see that the largest relationship is between physics and chemistry. And the reason is that around the beginning of the 1910, there's a new discipline, chemical physics or physical chemistry. And there is this interdisciplinarity, or the creation of a new discipline, physical chemistry. But there is very, very few people, in fact, there are 20 actors who happen to have papers in Journal of Physics, Journal of Chemistry, Journal of Mathematics. So again, by looking at the citing and cited journals, we can have a measure of the evolution of interdisciplinarity. And what's that? Okay, again, the centrality now not of actors, but of journals. You know, for the Century of Physical Review, which was been created in 1892, my memory is good, we look at a century of evolution of the journal Physical Review. And then, of course, we realize that at the beginning of the century, Physical Review is a peripheral journal in the structure of the field, and no surprise, Anna Physics, Physikalische Zeitschrift are central in the field. Then if we go at the other extreme, or we do it every 5 years, we can do a film with this, but the point is the centrality. Then, of course, after the war, Germany is destroyed. There's only one word, USA, and all the journals are centered on physical review. And so we have, again, an abstract structure that gives you a very good measure of evolution. Another way to look at, now we come back to economics, is that we were very much interested in the evolution of a new field that very few people know about, econophysics. Econophysics is, in fact, economics as seen by physicists. And the reason is this, it's not that difficult, is that there's a lot of people in physics in the 90s having PhD. There's no job in university. So they have to look somewhere, then look at data in economics. They find fat tail. They say, well, that's not new classic economics. It doesn't work. It looks more like phase transition in solid state physics. So we use the statistics of solid state physics, and we do economic analysis with this. So we said, okay, since in general, there are exceptions, and they are in the room, since economists are very open to other approaches, we say, how would they react to econophysics? Then we look at where they have their papers. And surprisingly, most papers in econophysics are in physics journal, Physica, ABC, or whatever. Even in Physical Review D on solid state or phase transition, and very few in economic journal, which just confirm the autistic view that economists have of themselves. They're not open to anything else. Of course, the physics community cites a lot of economic journal because they need data on their side, but the economic journal don't cite the econophysics. And then, so we can see the diffusion of the field or the not diffusion of a new field into the other field by using the co-citation analysis, which I think is a very strong. And then, of course, we can look at evolution of interdisciplinarity of economics, and we see that the top 5 don't move because they are closed on themselves, and in the periphery of the discipline, according to the top 5, then there is an opening to management, psychology, and a lot of more things. And we can look at the transformation of the subfields, and we name the fields by the titles of their papers in the group, and we apply a detection community, and we get the division of labor between specialties here for the end of the 1950s. There were quite a lot of number of subfields, and much later, it's more stable around 6 or 7 subfields. So we have can apply the same approach to any intellectual field and see what happened. And here is this evolution of the relative stability of subfields in the evolution of economics over 60 century. And just as an end, we did with a few of my colleagues, Thomas Pradeux, who is a professor of philosophy at the University of Bordeaux. He wanted to look at what is the use of philosophy of science in science journal. So he contacted us, he said, okay, we're interested in that. I said, okay, we have a few ideas of how to try to map this question. And of course, we did a paper in the British Journal for Philosophy of Science, and also in another paper in the Journal Synthèse. So I would just give one map of this, which is very interesting. Here we clearly see three subgroups. We have on the right the networks of authors who are mostly cited by Philosophy of Science journal. So it's Philosophy of Science for philosophers of science. And the community on the left, on the other side, are authors of philosophy of science who are mainly cited in STEM journals, though in really scientific journals, in biology and things like that. And then the community in the center are those philosophy of science who receive citation from the book. So that we have a group of standard philosophy of science or philosophy of science. We have philosopher of science talking with much interest. No surprise that we will find there for the 50s and for the 80s, even Schrödinger, who does some with the origins of life. So there's some philosophy of biology. Of course, the EPR paradox, we have some of physics. So it gives the structure of the community, which we call the, there's no such general thing as a relationship between science and philosophy. It depends on subfields. And here we clearly see that it's in biology where there is a lot of actors in medicine, of course, because of ethics of medicine. British Medical Journal, who is not a philosophy journal, will discuss philosophy of ethics because of the biological aspects. In physics, there's an old and long tradition, of course, of reflecting about the nature of quantum mechanics. So that's that structure of biology, medicine, physics makes sense about the level of interest in philosophy. We have bioethics, which is strong, of course, social sciences, and no surprise, engineering is not the place where there's much of a link between reflecting on philosophy and the sciences. So just to start the discussions, I give you the idea that with co-citation analysis, of course, there are other users of data. I didn't look at collaboration, that's something else, because of course in the database, the fields of departments are not well filled up. So we start to work to look at the data from the department addresses. It's more about the journal classification and the titles of papers and things like that, that we can really map the structure and the time dynamics of scientific field, even starting in the 17th century, if we incorporate the letters. Thank you for your attention. Okay.
Thank you very much, Yves, for this beautiful presentation. I failed to mention, but I mean, as you see, he needs no introduction in the sense that even this landscape vision of the field, which is a very important field, and the research program carried on by Yves. He's he co-founded the Observatoire des Sciences et des Technologies there in Quebec, and he is now the scientific director, and the center is exactly devoted to the idea of measuring sciences, and we saw many concrete illustrations of this. So now the introduction is done at the end of your presentation, and I evidently I leave the floor for the discussion. I think we can gather some questions from the floor. Yes, first of all. So you can come here and
Yeah,
or
that's what you want, yeah.
because there is no.
No,
Okay.
unfortunately for.
It's okay.
If you want to see you on the camera.
Yeah, they don't need me on the camera till later. But they need my sound, right? Okay, thanks for the wonderful talk, the very thought-provoking. So can I ask you to sort of elaborate on the theme? So your analyses, like the various maps, get at both epistemological and social relations. Are you in any position, at this stage in your career, like, you've got an advantage of decades of this, to sort of divulge or reveal to us some epistemological generations about the development of scientific knowledge that might be generalizable across fields? Does that, or across disciplines or subfields, beyond just the topic of each individual analysis?
If you are talking about the general sociology of sciences, then we clearly see that there is this epistemic similarities in most subfields. If we look at over a century, we get subdivisions and more sub-disciplines that becomes more and more autonomous. So there is, and there is also, I've been through all the data we did on this, but there is also, except for a few disciplines like I joked about economics, there is much more interactions between disciplines, and this is why I think we cannot separate the evolution of the content from the sociology of it. Because, for example, in all the debate about the rise of interdisciplinarity, now everyone talks about, oh, there should be interdisciplinarity. The chief scientists in Quebec always talk about, oh yes, interdisciplinarity, and now they even talk about intersectoriality. Intersectoriality, I don't know if it's a fad outside Quebec, but it's the chief scientist said, oh no, it's no more interdisciplinarity, it's intersectoriality. Saying, what's this? Okay, it's that scientists, physicians, so it's the social sciences collaborate with the scientists and the STEM. Whereas interdisciplinarity can be with historians and sociologists and philosophers. It's between the fields. So it's the fact. The problem is that if we look at the evolution of interdisciplinarity as we did over, say, a century, we see that there were phases of interdisciplinarity and a decline of interdisciplinarity in the 30 glorious, because the 45 to 75, there's a lot of growth in universities, a lot of specialization, and a lot of let's build our subfield, astrophysics or solid state physics. And so if we build our subfields, we don't have the time to look outside. And the discourse on interdisciplinarity changed. It's in institutional structure, and it goes up in the 90s. Why? Because now it's no more the scientists like in the 30s. They were talking, if you look at the text, they were talking about interdisciplinarity, because they were asking what is between the disciplines. And in the 30s, we observed that it was because of the economic crisis. They said, well, we have an economic crisis, the economists don't have an explanation, the sociologists don't have. So the explanation of the economic crisis must be between the disciplines. So it was a discourse on interdisciplinarity by the actors. Since the 90s, we see a rise, but it's forced by the institution. It's like internationalization. They want international collaboration between universities. The president of the university sign documents and they force us to. So in the data, we have to go back to why is it going up again? So it's more the general dynamics of the disciplines and the role of the government to push or not this thing. It's like the evaluation. I can talk about this because it's for tomorrow. So I think that we have more of this, and then we can ask the epistemological question, because in those data, it's like, I always say we are a Martian. We come back here and we have no clue what's going on. Then we have those indicators. We have three groups here. Why? Then we can go in the qualitative approach. Okay, the reason there is more in physics than in mathematics or less than in engineering. Then we go to the epistemology. But is it an epistemology or socio-epistemology? Because in the case of engineering, there's no surprise that there's much less link between philosophy and science. They look at building bridges. Okay, and we can imagine in the abstract that building bridges raises philosophical questions. I'm quite skeptical of this. So I don't have general epistemological conclusion, but always a sociological one. This is why my debate with the case with my friend in France, it's not a friend anymore, I think, because I wrote him in saying that this book is useless. So he didn't write back. He wanted me to read the book. He said, I look at your book and you don't mention any of the analysis done by sociologists who did show that Poincaré was not talking about relativity theory. He was talking about electron theory, which is a dynamic theory, not a space-time theory. It's a different thing, but the equations are the same. So for the physicists, so that's the anachronism there. And surprisingly, co-citation or even citation can bring back to thinking about why is it that Lorentz didn't see relativity in Einstein. The reason he didn't see it is also seen by the community. So we have the letters of one individual that comes back to the structure. So I'm more for multi-scale analysis. We start from the scale, then we can have a sub-question which is more epistemological. For example, if I had shown the details of the Einstein and Poincaré, I would have shown the structure, then go back to the very precise letter that Lorentz wrote to Poincaré and see that him did not see relativity, and then go back to the structure and say, no physicist saw that. A contrario, to show it that the proof is good, I took the case of co-citations in quantum theory. Starting in 25, 26, there is a lot of co-citation between the paper by Schrödinger and the paper by Heisenberg. Why? Because everyone was saying at the right time, they have the same theory. It's not me saying the same theory, it's there. In contradiction to 1905, 1910, very few physicists said Einstein and Poincaré. So for them, they were not in the same field. So the measure is very good. And again, it looks in through the methodological or epistemological questions about the nature of relativity theory and the naming of it. Because if we look at the detector, the naming of it is that relativity theory is not electron theory. The words are different because they refer to the concepts which are different. So again, it's always mapping the micro to the macro thing, and we can do it, I think. But that's not an answer, but that's the one I can give. Yes.
Hello, Arno Simons from Technical University Berlin. Thank you very much. You were mentioning the Republic of Letters and
Yes.
how people at the time, you have made the comment that people at the time couldn't see the data as a network, whereas now we can. And so my question is, what has changed at the time when we were able to see the data and when, in a sense, the mapping becomes a letter in the Republic itself? Because now we publish papers about such maps, we have databases, and we also have structures, incentivizing structures in science policy using these indicators. So what has changed through all of that in your experience? Thanks.
I'm not sure I understand what you mean.
Okay.
What do you want?
Maybe-
I'm not sure I understand
maybe-
the link between the Republic of Letters. Of course, a few people in the Republic of Letters did have this view. It's Mersenne himself, because he's the center of the network. He gets the letter from everyone. He's one of the few who knows everyone. But some people like Galileo never get out of Italy. And they don't even write letters much outside. They're not interested.
Mhm.
For example, there is a few letters from the Mersenne to Galileo. He does not even answer. And one of the reasons is that he sent to a friend, he said, I got this letter from Mersenne, but I just can't read it. It's so badly written, I don't know what he's talking about. So the singularity is why he's not answering, because I can't read you.
Can I
faster than-
specify, maybe to specify my question, it's more, I think I was pointing at or hinting at the performativity of our indicators,
The reflexivity.
the reflexivity. So the question is, because you say it's a working, you said why co-citation is better maybe than bibliometric coupling and etc. And we are debating metrics here, and there are links to philosophy. But my question would be in terms of the reflexivity, what changes when we use these indicators, when we think we found a good one, and what happens then science policy picks up on them, etc. So this kind of, yeah, thanks.
Yeah, and just come back to the beginning where I mentioned the case of the so-called disruption indicators. Personally, of course, I've always been very critical of this. I think, and in fact, I suggested that we have very precise criteria to determine if a given indicator is a good indicator of that thing. Of course, in some of the supposed criteria, they say the indicator should be valid, but of course, it's a tautology. The criteria I give is not the indicator should be valid. I give the criteria so that the indicator be valid. In the disruption one, because when the paper came out, there was a big fuss. So some journal in France called me about the paper, said that's garbage. I said that's garbage because I read at the definition of the indicator, and when you look at it, you say that's not a picture of disruption. Okay, so that's a problem. The problem is that they become reified very rapidly, because journals like Nature will say, oh, yes. And then people theorize, oh, why is there less disruption? But who said there's less? This guy, okay, but I don't care about this. So there is a real problem of multiplying indicators. Now there's a new indicator I saw in Nature or Science last week or whatever. You may have seen it. The C-square indicator. It's the analogous of the H-index for self-citation of people. You want to have who is citing himself and should not do that. So it's the number of your paper citing your own paper. So it's like the H-index, but for your self-citation. I said, but what's the point of this? Einstein at the beginning was citing himself a lot because there was nobody outside him who was doing the same thing. He was citing his paper on the Brownian motion. Say, hey, look, I did this paper on Brownian motion. It was self-citation. So again, we have to do good sociology instead. So the danger of indicators that you get reified, black box, we all know that. And then it's very bad because then the chief scientists will come back, say, use that, so we have to invest because there's less disruption. I said, no, there's no less disruption. There's just a bad paper that has been published in a so-called prestigious journal. So there is a real problem, but I think we'll discuss that more at the time of the day on research evaluation, which is a real problem. The problem now is that because of the bad effect on samptometrics of bad indicators and research evaluation, there is a critique of the methodology itself. Whereas what I put here, I put that citation and co-citation are central to understanding the time evolution and the dynamics of the changing relationships between science or like econophysics or any kind of question we can have at the structural level can be looked at with those databases. That's the main point. And we have to push back against all the multiplication of I'm sorry, but after the H-index or the G-index. Talk about this here, that's crazy. Okay. That's dangerous. That's used by institutions. And now they are black box in the Web of Science itself, where you push the button and you get the numbers. So this is the real problem that we have. And it gives a bad view of good bibliometric analysis.
Other questions? Otherwise, can I profit from my role well, I'm not, of course, an expert in such methods, but I'm very much interested in the use. And as you say, the difference that these databases and this way of looking at whole disciplines can make in our understanding of disciplines themselves. So I have in mind, of course, sorry again for my specialization, economics and your peculiar works in particular about economics' new interdisciplinarity, but also the fact that you somehow demonstrated that economics in the end closed itself in the post-war decades upon a few research lines. Now, my feeling is this one, that actually I strongly believe that specialization is the new factor, and economics in particular, I think, is now very much affected by specialization. And I think that this will make a difference and is already making a difference. So I am probably on a different line with respect to what you think about it. But my suggestion is this. In economics, we have less and less theory. Okay, there is this sort of applied empirical turn, which is probably also justifying this fragmentation of the discipline itself. So I wonder, this collapse of theory and this applied turn, this empirical turn, well, this might change somehow the landscape and justify perhaps the new openness that we see at stake in economics if we abstain from the top 5 journals and so on. The thing is that it is an unintended process, perhaps. So I wonder, first of all, your methods, how much unintentionality can they capture in the evolution of scientific progress within disciplines? So unintentional factors like specialization And second, whether this situation of fragmentation, of unintended fragmentation, of, let's say, fragmented pluralism, some call them, might this produce a new situation wherein journals have even more power than they had, just because they are the only pillars that remain in the discipline where theory has already collapsed? Thank you.
This raises an important question. I think that there is a general tendency, which I see in all disciplines. I have made my students done their thesis on many different disciplines, and this forces of specialization, which is also linked to overproduction. University, no, again, we have to look at the structure. The university will say, okay, we need more PhD students, we need more PhD. Okay, why? Then if you have more PhD, and even in 1840s, with the development of the domain of chemical theory with Liebig, you have the beginning of a specialization, because then you have a lot of PhD in chemical physics or in biochemistry. Then there will be a thesis, it's a caricature, but that's real. A thesis on atom of hydrogen, and another one on helium theory, and then on the other. So you have the same phenomena in economics. You have now, with the multiplication of journal, economics of health, economics of environment, economics of global change, economics of, and these become very specialized because the methodology is unique to the field. So that there is this book by Andrew Hadward on the chaos of discipline, and he shows the same things, that you have the discipline, it develops into specialties itself. If you are in astrophysics, you're not in astrophysics, you will be in planetary astrophysics or whatever it is, or black hole. So you will not be, and you have no way out of that. The only way out of that would be your speculation if you come back at the beginning of the 20th century. Then you have Einstein, you have the field of physics is built with about 100 persons. They look only at general things. And there's a classic case by Wolfgang Pauli, who developed, is supposed to be considered at the origin of solid state physics. And he says that's dirty physics. I stopped to do that because he got the principle, Pauli exclusion principle, you have the general field, that's enough. I do something else. I do theory of the universe, and then I stop there. But if you want to have 50 PhD students, of course it would not do that. And you have that in history. In my department, we have a history of economics. Now we have historians of environmental sciences. So I thought there's no way out of that. The problem, and that's my analysis, because I'm is the overemphasis on theory. And we see that a lot in sociology, And we say, oh, that's an interesting paper, but it's an empirical analysis. I said, but what? You want a new theory? And I think the overemphasis on theory in some disciplines explains, I think, I'm convinced that the emergence of regular new buzzwords. You reinvent the wheel by saying the same thing in a new way. 20 years ago, they invented new intellectual history. So what is this? It's intellectual history. But intellectual history went down the drain for social history. Then the new generation, we want to do intellectual history. They call it new intellectual history. I said, what's new there? It's field theory, it's Bourdieu's analysis of Derrida. Very interesting, but what's new there? So why is it that you have to invent new words in sociology to get a new theory? Boltanski theory of cities. I said, that's a description of very well-known things. What you call that? The city, industrial city, the city of, I said, it's a name on the thing. But I think there's no way out. The more the discipline will go, the more there will be specialization like that. And the difference with economics, that then the thing we have, the paradigm, new classical economics, you apply that. But if you look in the detail of the methodology, very often the results are independent of that. And it did not apply the theorem to that. It's not like in physics. There's no case in physics where you see, oh, I use the Schrodinger theory, but I call it the John Smith because it's not Schrodinger. That's not applied. They take Schrodinger equation, they find a new way to apply it to a complex analysis, but it's Schrodinger theory. It's quantum mechanics. It's not any. So there is a tendency of overemphasis on theory in some social science discipline like history, anthropology, sociology, political science. But even in those fields, if we take the field of political science, we will find it with 10 subsets which are relatively independent because they don't see each other. I don't think there's a way out of this. It's built in the dynamics of specialization, I think. Yes.
It's just a follow-up remark on that. I mean, it's insightful what you're saying. So I recently wrote a paper on Theodore Richards, the first American chemist to win a Nobel Prize, on his collaboration practices, so tracking 42 years of his publications. And I initially sent it to a history of chemistry journal. And yeah, it's been grown, as they should. The referee's report, it was almost juvenile. It said, it needs a theoretical framework.
Right, yeah.
And I thought, I don't know what that, I mean, this is rich in detail. If someone can use this, they can build on it. They can compare it to another scientist. They can compare it to what other scientists were doing at the time. There was no insight into that on the referee's part. So I ended up sending it to Foundations of Chemistry, and it all went fine. But this preoccupation with theory, and as you note that there's a premium on inventing and reinventing theory. So it's quite dreadful. I just wanted to share my opinion.
Yeah, no, you're right. Yes. That shows that with good social science, we can predict phenomena like that. With no surprise, it happens. We have to do it. Again, now if we extend it and we look more abstract, because now, of course, I think the most new thing that we add is that this we could do a lot of the cohort. Calon did the coordinative when we did not have much data. We had keywords, but now we have full text. With the full text, we do in fact the same thing, but in a more complex matter, because we can go beyond the cohort and we can make really a textual analysis and see the similarity of topics. And so but the dynamics is essentially the same, trying to understand the transformations at the text level and correlating it with the institutional aspects and the international collaboration. Because in the international collaboration, it's not a random link. And those are linked to history. For example, in Quebec, we have more links with France. In Ontario, there are more links with England. Because, of course, it's a colonial approach. Okay. So I think we are rich enough. And it's left a theory than a general framework. You add a general framework. What is the dynamics of this chemist? How is it developed? It's an empirical questions. So that's why I say my students said, you need the research question, not the theory, research question. And then you have to explain that. And then to explain it, you will need, for example, I use implicitly in all my works, of course, Bourdieu theory of fields. It's behind the data, but also it structures the data, because if you have a theory of fields, you will think in terms of space, and then you will think in terms of subspace. But if you don't have a theory of fields, you will not have this approach of center, periphery, and try to operationalize it with an indicator that is valid. So again, you need a general conceptual framework, but it's not a theory. And there is a bad use of the word theory, if you want. They mix concepts with theory and with words. A lot of new words are not theoretical. This is why I'm against, I'm sorry to say it, but I'm against the use of digital humanities. That's empty. In my department, they opened a job in history department. I said, no, we won't call this. We'll call it history of something. And if they do quantitative approach of this something, history of economics or history of environment, it's okay, but it's not a field, the digital humanities. We were doing that for much before the name. So we have again to go to the content and the methodology and the specificity.